Dear student, this is Alok Vashishth. Today we are going to start our topic continuity and differentiability. Our basic concept of the continuity is based on the concept of the limits of class 11th. Basically, what is the continuity? A function, if it is continuous, we are saying, then it means it is continuous in its domain and its graph is a curve without breaks or jumps throughout its domain, and a function is continuous at a point in the domain if its graph does not have break or jumps in the immediate neighborhood of the point, that is left hand limit or right hand limit. Basically, as I have shown, this is the graph. There is a point. At this particular point, the graph is going to break, and if there is no point between them, that is if we are moving from this to this without any break, then the function is continuous. Basically, continuity means if we are drawing a curve of a function or drawing a graph of a function, and without lifting a pen or without lifting a pencil on a piece of paper, if we are drawing it, then the graph is continuous, or you say the function is continuous at that particular point. And if we are talking about a function, that whether it is continuous in its domain or not, it means throughout its domain, if we are drawing the curve in the complete its domain, it must be continuous without any break. That is, if we are saying about a function fx is equal to x, then it is simply a line and it can be drawn without a break. Now further we will continuity we are talking about now, continuity of a function at a point. Here now, with the help of the limits, we are going to describe it. A function fx is called continuous at a point a in its domain if and only if we are saying limit x tends to a, fx is equal to fa. It means this limit is including both left hand limit, that is with the indication of a minus, and right hand limit with the indication of a plus. That is, if left hand limit at x is equal to a, right hand limit at x is equal to a, and value of the function f at x is equal to a are equal, then we can say the function is continuous at that point. Now we are proceeding for algebra of continuous functions. We are supposing the two functions which are say f and g, and these are the real function we have considered, and these are the continuous function it is given, and suppose alpha is a real number, then our results are the sum of the two functions is continuous. Again, if the two given functions are continuous, their sum is again continuous. Their difference, that is f minus g, is again continuous. Alpha is some real number and multiplied by any function, say it is f or it is g, it is again continuous at x is equal to a. The product, that is fg, is again continuous at x is equal to a. F upon g, that is the quotient of the two functions, is again continuous at x is equal to a, provided that their denominator is not equal to 0. We can take the another example of g upon f also, and in that case fg is not equal to 0. So now we are taking its 6th point. If we are taking 1 upon f of a function, we can take 1 upon g also. It is again continuous at x is equal to a, and here again denominator is not equal to 0, that is fa is not equal to 0, that is the function's value at x is equal to x is equal to a not equal to 0. Now we are testing the continuity of a function. For example, we are taking a function fx is equal to 2x plus 5 at x is equal to 2. Initially we will write the function fx is equal to 2x plus 5. Then we will say we are talking about the limit x tends to 2. Simply we will write the function. Now limit x tends to 2, we are putting the value of fx is given 2x plus 5. Then we are putting the limit x is equal to 2. It means x is replaced by 2. 2 into 2 plus 5 is equal to 9. It means the value of the limit is 9. Now we are taking value of the function fx is equal to, put x is equal to in the given function, it is 2 into 2, that is 2 into 2 plus 5 is equal to 9. So limit x tends to 2 fx is equal to value of the function is equal to 9. Therefore fx is continuous at x is equal to 2. This is one of the examples. So we have completed. Now we are taking exercise 5.3. We are taking about that is the question number 1. Fx is equal to 5x minus 3. At x is equal to 0, we are checking its continuity. So we are saying limit x tends to 0 fx. Now value of fx is given 5x minus 3 we have written. Now we are putting the value of limit x is equal to 0, that is 5 into 0 minus 3, the value is minus 3. Now we are writing value of the function, that is x is equal to 0. In the given function we are putting x is equal to 0. 5 into 0 minus 3 is equal to minus 3. Therefore limit x tends to 0 fx is equal to f0 is equal to minus 3. This means value of the limit, this means value of the function, and finally the answer is minus 3, which is matching. Therefore function fx is continuous at x is equal to 0. Similarly we will prove that at x is equal to minus 3 the given function is continuous. Now in spite of x is equal to 0, as we have done earlier, now we will put simply x is equal to minus 3, then x is equal to minus 3 again. Same function fx we are going to copy, it is 5x minus 3. Now at the place of x we will put minus 3. Now 5 into minus 3, finally answer is minus 18. Now we are taking value of the function f minus 3, it is 5 into minus 3. In the function 5x minus 3 we are putting the answers. 5 into minus 3 minus 3, that is finally minus 18. Now limit x tends to minus 3 fx, this is the value of the limit, is equal to value of the function f minus 3. Both are matching, answer is minus 18. Therefore fx is continuous at x is equal to minus 3. Similarly at x is equal to 5 we will check, and limit value x tends to 5 is value is 22. Similarly f5 is 22. Therefore limit value of the function, finally it is 22. So fx is continuous at x is equal to 5. So in this way our question number 1 is completed. Now we are approaching to question number 2. Here it is given fx is equal to 2x square minus 1, and we have to check the continuity at x is equal to 3. Now limit x tends to 3 fx we have written, because at the 3 we have to check. Now function we have to copy 2x square minus 1. Now at the place of x we will put 3. So 2 into 3 square minus 1 is equal to 17. Now f3, that is value of the function, 2 into 3 square minus 1 is equal to 17. Therefore limit value of fx is equal to f3 is equal to 17. Therefore fx is continuous at x is equal to 3.